Morning, Mark.
Good morning. Just gonna give people a couple of minutes to join.
Having looked at that background for a while, I'm fairly convinced it's a Raspberry Pi or one of those Arduino single board computers.
It might be. It's a stock image I downloaded from somewhere. In the age of remote work, background is one of the best innovations because no one ever knows where you are.
I know I have action items on documents to review.
Yeah. All right. So we might as well get started, and people will join. They join because it is the weekend, or the holiday weekend rather. Oh.
We will have a lot of people out, I'm sure.
Yeah, that's okay. No, we'll do what we can with what we got. All right. So, oh, hi, Alec. I saw your note in my document.
Yeah, it's a strong doc. I enjoyed reading it.
Oh, it's simple rather. Okay. So I'm sharing my screen now. And let's start with this. So we are going to be presenting maybe me and maybe one other person, maybe Steve or Mark Bauer, to the Zero Trust Architecture Working Group from CSA. They asked that this not be an open meeting, open to all, but I just want to show the content that will be going in there.
Yep.
So Zero Trust means many things to many people. So I basically went with the NIST definition of it. So I pulled up this document, SP 800-207, and there are two sections in it that are relevant. So there are the tenets, and there are 7. The ones that are in bold here are the ones where I believe the confidential computing can help, and you can see that it's actually all but number 2. Now, I could even make it all, but it's just that.
Did you bold it based on the fact that everything bold you believe has a confidential compute impact?
Yes, yeah, or can be impacted by confidential computing. It can be done better with confidential computing. So let's first of all, I'm going to take this and I'm going to put the link in the chat.
I just did.
Oh, you did? Okay, great. And then I basically created a slide, and the thing that's unfortunate there is that there's just so much duplication between these slides. But for each one that I bolded, I basically have 2 panels: what happens without confidential computing, what happens with confidential computing. and then we'll go through them in a second. But if you scroll towards the end, there is another slide, which is the zero trust view of the network, which is also out of the NIST document. There are 6 items on that list. And here I didn't bold anything. I didn't create additional slides, simply saying, look, under consumer computing, device ownership and location, are just not strong factors, simply because ultimately it doesn't matter. It might for regulatory reasons in terms of, where's the device located if the regulator actually cares about physical location, but that's device metadata. That's not device security posture. And finally, last slide is there are 3 variations of zero trust architecture approaches, and I believe that only the first one is actually impacted by confidential computing. So confidential computing will not help you with microsegmentation. It will not help you with software-defined parameters of your network infrastructure. In fact, I would go as far as to say that with confidential computing, like the reason 2 and 3 existed is because we didn't have confidential computing to help us along, but that may be too strong a view for the zero trust architecture group. So let's go back through the slides. So again, the slides 3 through 8, 6 slides that are each 4 bolded ones. So you'll see, so all data sources and computing services are considered resources. And so you can read, I don't need to read from the slide, what happens on the left without confidential computing, what happens with confidential computing. Now,
Hey, really quick, if I may interrupt, I know there's a Victor Liu. I'm taking notes in attendance. Victor isn't somebody that I've met before. Can somebody give me a quick introduction so I can capture that in the notes? Or has Victor introduced himself to the team? If not, I kind of wanted to make him welcome.
Oh, thank you. I'm independent, sort of an amateur, so participating in a lot of open source communities, especially in the area of security is one area I'm very interested in. Actually, what you describe here, I'm actually co-authored so-called cloud native zero trust computing white paper. So this is what you on screen here is very interesting to me.
Awesome, awesome. Well, is this the first time you've attended a meeting?
This meeting, yes, yeah.
Well, welcome. I just wanted to make sure that you understood that, as part of the Confidential Computing Consortium, have you attended any of the Confidential Computing Consortium Technical Advisory Committee meetings or any of the other special interest group meetings as part of that group?
Yes, I attended other confidential computing meeting. This meeting is first time.
Okay, awesome. I just wanted to make sure you understood that it was open, free, open to the public, and that we encourage participation from everyone, and that we're super happy to have you joining our group, and hope you become a frequent collaborator. Can you give me, if you don't mind, sharing in the chat your email address, just for the purposes of note taking, since it is a public meeting, and I'll capture that. You won't get any emails. We don't share this information intentionally with anybody, but they are public documents. So thought
Okay,
I'd
yeah,
let you
no
know that.
problem.
And also, I wanted to point out that Steve Van Leer has a colossal shirt on. Nice work there, Steve. You're bringing up the curve.
Thank you.
Sorry for the interruption there, Mark. Please continue.
yeah. All right. So
100
again,
degrees here yesterday, so I got to do something to stay cool. Break out the Hawaii garb.
to your comment, Alec, about need to differentiate between device admin and OS admin. So device admin is effectively always, out of the TCP under confidential computing, effectively. And that's why I mentioned device admin. OS admin I did not mention, because if you have a confidential VM, then the OS administrator is, in your TCP. And I think, when zero trust architecture people look at zero trust, they worry a lot about devices. And I think the primary thrust of the meeting, I'll tell them, like, you actually, once you replace device identity with workload identity, you're, the
I
things you
think
need to worry
that's
about.
probably the fundamental thing that they maybe need to slide between 2 and 3. The notion that because to your point, to be successful with zero trust, you have to trust the device. And by extension, you've got to trust the admins and everything else that trusts the device, or that's how you set up your initial proof points. And confidential compute is a way to remove and decrease the size of that circle of trust.
So how, feel free to propose a slide. Again, trying to keep slides short. And I do mention multiple times about like devices, but yeah, we'll feel like, why don't you go ahead and add something? And then as we proceed reviewing the rest, in the interest of time, we'll come back to what you just put together.
Do you care if I put hosting device administrator in the column on the right, just to make it clear? And keep it consistent with the column on the left?
Sure, go ahead.
Cool.
All right, so slide 5. Here, this document talks about access to individual enterprise resources is granted on a per session basis. And here I'm basically saying, look, if you actually take a look at, say Kerberos, you get a ticket granting ticket effectively for your machine, and then multiple services running on the machine may, in fact, have this. And individual service tickets will still be sessions. But I want to draw attention to the fact that under confidential computing, every trust execution environment is its own security principle, and any communication that establishes becomes a session that certainly other trust execution environments, even on the same machine, cannot hijack or make an improper use of. So it may, I don't know how it will play, but I'm certainly drawing a comparison between shoving all your credentials on a into one TCB versus having separate ones. Next one would be access to resources is determined by dynamic policy. Yeah. So without confidential computing, pretty much, you're limited to in your choices of ways of securing your identity, and device identity might be TPM based, I suppose. So it could be trust on device in some cases, but the workload identities are usually associated with bearer tokens. My understanding of bearer tokens, which is a little bit more strict than what I see out there. Even X509 certificate is a bearer token if the private key can be leaked. And if you're not trusting your admin, you're certainly not trusting how the private key for X509 is protected. And again, you might be able to do something with some sort of enclave or something that protects just the key. But with confidential computing, you attest the entire workload. You can even compare the measurements presented against the bills of material that you get out of band, and your dynamic policy may, in fact, if a flaw is discovered that is reflected in a bill of materials under confidential computing, you can immediately start denying access to any workload that has that vulnerability in its bill of materials. That's sort of the thrust of this slide. Under 7, enterprise monitors and measures the integrity and security posture of all own associated assets. Again, this is because you have remote attestation. You actually have a much better chance of monitoring the security posture of things than you do if you have to pay attention to with maybe intrusion detection software, whatever, but you have to invest considerable resources in securing your devices because your TCBs are too large. And this is, again, another thing I want to impress upon the Zero Trust group is with confidential computing, your device security posture is diminished in stature. All resource authentication authorization are dynamic and strictly enforced before access is allowed. And again, coming back to the same thing, with attestation and access to things like bills of material, you have a more dynamic authentication authorization. and claims that are strongly tied to workload identity. So now you have strict enforcement and unforgeable claims. And I have a typo here. Okay. And finally, the enterprise collects as much information as possible and uses it to improve security posture. So on the left, today you have to rely on endpoint security solutions and sort of behavior monitoring and things like this. And with remote attestation, your data collection is trustworthy and you collect only what's really relevant. You don't have to pay attention to it. There will be fewer spurious signals from all over the place. Anyway, so that's in a nutshell. Let's come back to flight 3.
So sorry, I'm almost done, I think.
Yeah, no, this is good because look, I'm somewhat uncomfortable with the fact that I have to repeat the same thing like 6 different times in the version of the deck that I put together. And if we could somehow summarize it all on one slide and basically, go over these are your 6 tenets, but
Well, that's exactly what I was trying to do. Was you make a claim on slide 2 that confidential computing impacts 6 of these 7 tenets in a unique way. Why are we making that claim? We're making that claim because trusted execution environments are a subsection of a machine that are attested and known to be in a good state, if you will. That fits really, really well with the definition of healthy devices. And if you think of a healthy device as an attested workload in a TEE, then you can eliminate
I would even say machine owner and admin.
Which comes back to Alex's comment from slide 4. So instead of having to repeat this over and over, this is the big idea. If you buy into this, that a TEE is a healthy device, right? That you can get to a known state, which means you can prove it's healthy. Then the impacts that you define in 4, 5, 6, 7, 8 all kind of fall from this one concept.
Yeah. And again, we will probably need to move on from this to finish the work on other things. But Steve, if you want to gut this deck and replace my 6 slides with 3, as you have it, to shorten it, I think that would be great because I want to spend less time presenting the deck and more time on discussions. So, but it would require careful wordsmithing. So, how about, or you and I can also follow up offline in the next couple of days.
Can you guys give me a little context as the rationale behind this deck? Was this as a result of a comment that took place yesterday in the CSA meeting?
In the CSA meeting yesterday, we were talking to Ryan, who is our the CSA rep in our joint working group, and we were talking about getting in touch with the Zero Trust Working Group, and he said that they're open to meeting with you, and their meeting is next Tuesday, 11 Pacific, and they want a few participants, so they would take like maybe a couple of people, so that would be me and either Mark or Steve, and or for all of the people who were on the call yesterday. And I basically said, okay, we'll put together a deck to present to them our thoughts, because confidential computing is, no question, a game changer for Zero Trust. It turns, the way I phrase it is, it turns Zero Trust from an aspirational thing to a real thing.
Sounds cool. Awesome.
Yeah,
that's good that you guys are getting inroads with that group. I look forward to hearing a readout of
very
how that
exciting
conversation goes.
Very exciting development. Yes. So we'll see how it goes, but perhaps we can do some joint activities with them as well.
So the way I'll make another skim through the deck. I think your slides are all good. As I read through them, I think they expand upon the various points, and then you kind of sum up at the end. So all I was trying to do is, what are we going to argue about again and again and again? We're going to come back to this concept of machine trust. and healthy devices. And so this is, if this is the concept that settles in, that confidential compute provides a way to define a area of compute, a zone of trust, if you will.
Yeah, I would title this slide differently. I would say under confidential computing moves from machine trust to workload identity. And I think that's the key. Like I've been beating this drum for a little while now, where it's the workload identity that we actually care about. And if you know exactly what your workload identity is, and it cannot be tampered with, by extension, all the data that this workload deals with is that workload, nobody else. So yeah, so that is what we want. And if we get there, I believe we really, as I said, moving from aspirational to real.
Yep.
And I do not know if two concepts work incredibly well together. They don't. The whole point is one supplants the other.
Yeah, well, that's why I wanted to make, this could be an argumentative slide. And certainly the title is provocative to a zero trust crowd. So I think that bullet point.
The point is you worry about fewer things.
Yes.
Right. You no longer worry about where the device is located. Zero trust would like you to.
What you care about is the workload running in an environment that it matches what you want that environment to be? Is it
correct?
The configuration?
Yeah.
Yep.
All right. So okay, you and I will follow up offline. I will need to move off from this so we can get other documents approved. So first, let's do a really quick one. So I would like to move it to approved status so we can move off of it. We've done little review on it, but it's kind of a short and uncontroversial document. So this one is workload upgrades. And the idea is where you have a large number of nearly identical instances, that may differ by, I don't know, location, maybe. And these distributed applications are less tolerant of downtime. And now when you do updates, or sometimes you do blue-green deployment, you will gradually roll out the update. And in some cases, you may need to roll back. So that's a common thing. But under remote attestation, you will find yourself in an overlapped state where both old and new versions of the application are likely to coexist. So your rollout automation needs to involve your attestation service. And this is what really this is talking about. And I'm actually going to delete this comment because I reviewed it and I no longer care about it. But yeah, so sometimes you need to update within a given time interval. So maybe you have a highly critical vulnerability and you need to go and update your instances to get rid of the vulnerability. But you still may not be able to tolerate downtime. So the idea is to integrate in such a way that once a new workload version becomes available, the AVS policy should allow both the old and new versions of the workload. And then as the update completes, we go and phase out the old version. Or if the update fails, we phase out the new version. Okay, this is the picture. And I only had a question because I talk about workloads up there, and should I replace the word image with workload? I probably should, because image is a new term that is not really used anywhere else.
Yeah, I mean, image gets used these days because everybody's talking about confidential VMs.
Yeah.
But in the context of the pattern, we're talking about workloads.
Yeah. comments.
Got one more, bottom left.
I feel like I need to make some of these boxes a little larger now. Okay. All right. So that's that. Resolve the comment. And that's it. The on the expectations matrix, which is this document, and Victor, for you, we have this expectations consistent participants document that basically shows the generic relationships of expectations. In here, I claim that the only one that's really affected is the 7. So 7 is the developer of the application as it goes and deploys the new workload. Needs to update the AVS provider with the new policy, and that's the only accountability there. Anyway, so with your permission, I would like to move off of this document and basically treat it as completed.
I think that's okay.
Okay, great. So this one is almost done. This is confidential payload governance. I would also like to move it to approved status today. And then next time, running ahead, I would like to start with attestation verification governance.
Okay, so just to capture this in the notes, the workload upgrades document is approved.
Is approved, yeah.
And the other pattern document that we have
is the confidential payload governance. That's the one we're seeking to approve right now.
Yes. Okay. Got it.
So Nikolai, who's not here, wanted to make a change of wording. I'm inclined to accept it.
Yep.
Okay. All right, so let's, Nikolai is not here. Unfortunately, I usually prefer not to resolve comments in a person's absence, but I really do want to move forward with this. So please read this message exchange on the right and see if you want to.
Can you click show more on your rebuttal? I mean, I don't want to open the can of worms. I don't understand how a T can guarantee the transit of log information once it leaves the T.
It's a key management thing, right? So if you previously would simply call some sort of an API for your log and say, this is my log, and you trust that the control panel secures them. Here, you need to be consider if you actually trust your control panel or not. And if you don't, then you may want to say, I'm going to establish a shared key with the eventual recipient of the log information, and then I would like to turn my log into just a dump pipe.
We have a whole bunch of configuration items all around how to manage logs for this very reason out of our product.
So you are basically confirming my point, I think, in the sense that you are, you do have to take this into consideration. You can't simply, continue with unmodified and not pay attention to what's going on.
That's right.
Right. So
We view everything that comes out of the TEE has to be managed some way, and logs were one of the first things that all of our customers wanted to get their arms around. How do I know the logs are going to the right place? How do I know they're secure? How do I know on and on and on?
Okay.
So, all right. So then I'm going to accept, basically resolve this and leave as is. And finally, there is a discussion here. I added the wording basically saying if you were issuing, and this is the new metaphor I use, is using confidential computing with bearer tokens as a suit of shining armor made of tinfoil. And the idea is if I give a trust environment a bearer token, it by itself will not leak it, of course, but it will be presenting that token to some relying party. And if that relying party leaks it, all of a sudden, we no longer can know that the workload identity is, who it claims to be.
Yep.
That's right. And today there's got to be a translation between the CC world and the non-CC world. It's too big a leap to have everybody change the way they do identification for all their apps in one day.
Yeah.
And so things like MAAs, things like our policy manager are those bridges. Where you've got an attested piece of code that's going to hand out the tokens as opposed to just connecting into an existing token system. But once you hand out those tokens, you're now relying on the security that you had before.
Yeah. Well, so I'm also looking into, there is apparently a new document, new standard that I've started looking at yesterday, having something to do with OpenID for financial services, talking about as one of the things as figuring out how to bind your JSON web tokens or whatnot to an issuer. And right now, unfortunately, they are just bearer tokens. And so I, as part of confidential computing working group, generally, not just this one, not just governance, we should probably raise awareness of, issues that people might run into. So, then eventually it's ultimately up to its adopter's choice. If they want to continue using bearer tokens and they understand the risks, nobody's stopping them. This is, I would say, you should later on consider using bound tokens for your authentication.
Bound tokens, is that the same thing as proof of possession?
Yeah, bound. So, for instance, if my token is around a private key that is generated inside a trust execution environment and would never leave it, then it cannot be used by anybody else. And this is the ideal state.
But it's not proof of possession in the sense that I call a method inside of your T to verify that you still own the token.
No, it's simply the key is not exportable.
Got it. How does the relying party know that?
Well, the relying party might know this transitively from the fact that it trusts this this workload.
Okay.
Yeah. Okay, so I'm gonna accept this change. And there is a conversation with Dan, but I explained my answer, and I just added to Dan's comment that the token might get leaked by some relying party. And at that point in time, anyone can use the token once it's leaked.
Sure.
Yep.
All right, so there is, let's see, there is another Nicolai's comment from this morning. I haven't sent this one yet.
Yeah, from a computer science point of view, I think a confidential VM is an unreasonably large TCB, and all sorts of things are going to get stuffed into them because it's a full VM. From from a practical point of view, that's where all the hardware is, and that's what we're working with. So we can point it out, but it's I don't know that it's something that I worry about from a pragmatic point of view.
Right.
You are making a pretty strong statement. Lift and shift of unmodified workloads will be inherently less secure.
And I do disagree with that, right? So if I take a application like HashiCorp Vault and I put it into an enclave, I actually suggest that it's significantly more secure than running it outside of an enclave. Now, could you make it even more secure than it is? Yes, you could partition it into multiple pieces and you could get the TCP even smaller. Down that path lies HSMs, where you do your cryptographic functions in an untamperable machine.
So how about maybe less
This is where,
secure?
from a theoretical point of view, the answer to this is always going to be yes, it is less secure. But from a practical point of view, I think the security benefits of moving a unmodified workload into a TEE is significantly safer than trying to hire a bunch of engineers and re-architect it.
Yeah, but I'm comparing the security not against what it was before lift and shift, but against what it might be then if you were to take care and repartition the workload for minimization, right? So, but I don't mind softening the language because I don't want to, it to be a distraction. Ultimately, what this bullet is trying to say is don't lift and shift, but prioritize, like try to repartition if you can, and try to explicitly minimize your TCP if you can.
For the recommendation I give to customers is don't try to take an existing VM and just turn on confidential computing.
Right.
But what you want to do is you want to focus on what's the workload versus what's the environment, and you want to lift and shift the workload, not lift and shift the environment.
Mm-hmm.
Maybe a better way to phrase it.
Yeah.
Right. Take the workload, stick it in a container, and then manage just that workload, as opposed to sticking the OS you happen to have lying around because that's what you did in VMware, and enabling that.
Right. So, okay. So Nikolai suggested wording that
Maybe
I don't
say
mind using
lift and
his.
shift to unmodified environments is less secure than repartitioning workloads. So if you just change the unmodified workloads and call it environments, right? So if you just lift and shift a VM, that's less secure than lift and shifting a workload.
But ultimately, VM is a workload. If you're talking about a confidential VM, you measure the whole thing.
Well, we break the VM into pieces, so we always communicate what's the whole thing versus what are the components in there, so you know the difference. But that's a feature of our application.
It's just an environment could be like environment variables. It's not. I don't want to use terms without defining them.
Let me give you, I don't mean to throw Google under the bus, but Google's got a checkbox that when you're creating a VM, you can choose whether to have that VM be confidential compute or not confidential compute. It's literally just a checkbox. If you just check the box and I've got a machine instance that I'm going to run in confidential compute or non-confidential compute, I would say you haven't bought yourself much by just checking that box.
Right.
Right? Because if you want to attest that, what you do is you spin up the environment. After you spin the environment up, you log into the environment. You say, hey, what was your attestation result? Got it. And then you use that for future times when you spin up the VM. You don't know that nobody's tampered with it during the boot process. You don't know that it was unmodified from when you built it. There's all kinds of problems.
Sure. So how would you?
I was trying to find the easiest way to rephrase this, and I think lift and shift of unmodified environments may be less secure than repartitioning workloads.
Okay, as I said, like environment, if we're going to introduce this term, we need to start adding it to a glossary somewhere. It needs to actually have a meaning that one can look up, because it, I understand you have an understanding in your head of what environment is, but it's not something that will easily transfer.
You want to say unmodified VMs?
Well, we don't see that's again, I don't know. The workload has a very well-defined meaning. It is a thing that you presume will be operating on some data.
Take a look at the I'm just trying to break a logjam here. Take a look at the other words that I threw in there. See if any of those strike your fancy, Mark, and maybe yours as well, Steve. I'm just listening to what you said and tried to phrase it there.
VMs are a big part of why this bullet exists. But even if I'm going to run something in an enclave, like so, sometimes I can take a VM and with a shim around it inside an enclave. But I'm really talking about, here's some code. I would like it to be executed confidentially. As part of that, I would like to take a look at it and remove things from it that should not be in the TCB. And we don't really think about it today. Today, you just, you pick up a VM and you run it, daemons and all.
So we don't recommend to any customer that they pick up a VM and run it daemons and all. So I have in all these documents always used the term workload to be defined as the application, the code that I want to run typically in an operating system. And we recommend for customers not even to put an OS if they can get away with just the kernel. And not have all that extra stuff in the TCB. And so maybe we do need to have a definition somewhere that defines what is all the other stuff besides the workload. Why did we work so hard to create the term workload independent from any other term?
How about
and we may have to define this up earlier somewhere in the document, because I don't see any way around.
Okay, so how about we'll say unmodified
the application is different than the daemons and all the other crap, as you just said.
So how about we'll say unmodified code execution environment, such as a virtual machine?
So I had offered up just a VM earlier, and if the extra words mean we don't have to do a definition, I'm all for it.
I like the sound of that.
So that was a yes. I'm happy with your proposal.
Okay. Would that be acceptable then?
Yeah, I think that makes your point.
Wouldn't be a standards body if we didn't argue over words. Can you hear all the construction noise on the phone or no?
No.
Not a bit.
Okay. What is this? Okay. I think this will already been addressed, so I will.
Well, I think what he's saying, let's look at the top 3 bullet points just really quick. Unnecessarily large TCVs, yeah, okay. Trusted routes are essential for establishing and verifying secure communication. Yeah, what you're saying is
He's saying that this is not new for
certs.
confidential computing, but my point is actually for confidential computing, I have a chance of attesting my trusted root store. I can take a perfectly, perfectly secure workload that has no bugs, but then I give it a bad trusted root store, and all of a sudden it trusts things it ought not to trust, and your security guarantees are severely diminished. So I basically this is the forces section. Under solution section will basically say attest your trusted root store.
Okay, so what I would say then is that your point's not coming across here. It's not that you're not arguing about the fact that you, sorry, let me form my thoughts a little bit more clearly. The point you're trying to make is that you cannot validate whether your trusted certs.pem file has been, it has integrity. You can't validate that cryptographic parameters in OpenSSL have integrity. So I would, the fact that you're picking specifically at trusted certs.pem, or you're picking at OpenSSL config, isn't relevant. I think what you should say is inability to validate critical security configuration items, for example, trusted root
Well,
certs and
it's
cryptographic
not that it's
parameters.
an ability to validate. I guess so. If you take a look at how today's execution environments function, I will have a container image, for instance, and then separately from the container image, I give it a bunch of configuration. So run this container, but with this trusted root store. Draw this container, but these are cryptographic parameters or whatever. And
but there's a whole bunch of other stuff. You're fixating on two things here, and you're directing a reader's attention to two specific things: trusted certs.pem, OpenSSL CFG. There's a ton of other stuff that you also need to attest to, whether hypervisor disabled is set, whether, you know, that there's a million security configurations. And what you're saying is what you just said verbally, which made a light bulb go off that I didn't get by reading these 2 points, is there's a whole bunch of shit that you need to validate before you can trust execution environment. Two random examples are your trusted roots and cryptographic configuration. There are many others, but it's your inability to measure those important security parameters that are
this is
important
right here. Configuration environment settings during execution. And I can say, comma, some examples being.
Cool. Then you could, yeah. Okay. And I'm fine, but you really go on to draw close attention to two random security configurations.
Well, random, but very, very important, because these are the kinds of things that happen all over the place now. Yeah, this is not intended to be a complete list. This is intended to be more of a, you know, some things you ought to pay attention to.
Okay.
Then I think it should say that up at the top, as Alex just pointed out.
You could shorten this thing by just combining the second and third bullets by saying, for example, trusted root CAs and misconfigured cryptographic parameters are common examples that should be measured before you trust a workload.
So how would you rephrase this?
Here, I just say, let me come back to this thing here.
We have unnecessarily large TCBs. So there's a category, right? We can say that. Then in here, we could say, you know,
There, something super short and sweet like this.
well, inability to validate. This is the forces section. We don't have an inability to validate, right? That's not the problem. The problem is we may forget to treat something that is security sensitive as such. It's not inability. Ability is there.
And let me read the whole
It's
section.
more of a question of willingness and awareness.
Secure packaging Okay, so that talks about unnecessarily large TCBs. Secure integration, not sure about
Integration
that.
would be I'm integrating this piece of code with this configuration.
Okay, and then secure configuration and deployment. It's the third one there that you're trying to give
Integration and
examples of.
configuration to me are kind of the same. Configuration is choosing what configuration, and integration is sending them together to the same place and knowing that they ought to play together. Deployment is more along the lines of AVS policies.
Okay, so you're giving examples of integration and configuration as the second and third bullet points. And you've just said that integration and configuration are closely related. So
Yeah.
what I'm saying is an example of sensitive configuration is critical security settings such as trusted root CA certificates and cryptographic configuration parameters. And it's just shorten it a little bit. And I think maybe that'll address yeah, what Nikolai's saying is that what Nikolai's pointing out is that these things apply equally to non-confidential
Oh,
OSs and
yes, I
confidential OSs.
completely agree that there's important everywhere. It's just under confidential computing, you get a chance to validate them. So you should always be careful about them. But under confidential computing, I can actually be sure through attestation, if I choose to include it in the measurements, that it is in fact the thing I expect.
Okay, well, there's nothing in here I disagree with. I would just say maybe you're over elaborating a little bit. Trusted root certificates are essential for establishing and verifying secure communications. Yeah, okay. Certificate signature integrity and authenticity are fundamental to security, operation, and infrastructure trust. That's like computer science 101. Does it belong in this document? Is it specific to confidential computing? As an example, sure, it's a good random example, but you're explaining why it's necessary, and maybe that's a little bit. Maybe Nikolai is trying to say that's overdone. Sorry, go ahead, Steve.
Could we just put the words examples include before trusted roots?
Sure. I can say as another example, and
there you go. Perfect. I'm fine with that. They're both good examples, and I think Nikolai's point is only that they're generic examples, and I think you just made that clear by adding for example. That's cool.
Okay, great.
Good enough.
Yeah. And then the whole section is, it is important to know what your security configuration is. And it should be attested.
Yeah, and that's under solutions. So here we're just listing problems. Okay. Why is this selected? Why is there color on this?
Because Mark's got it, or Alex got it selected.
Oh,
Got
I see.
it.
Okay.
I just took it off.
Okay.
The joys of Google.
Okay. This is Mark Bauer comment. Steve, maybe you can speak to it.
Oh, what he's just saying is attestation verification only proves that the values are treated as valid at boot time. Although you could rerun attestation subsequent to boot time. But
well, ultimately, whatever you measured at boot time is what allowed everything else to happen.
Well, I think Mark is campaigning. Okay.
So yeah, I mean, the at boot time is important because that's the way all of attestation works today. If you wanted to do a running attestation, you could certainly rerun the attestation process, but the configuration of the machine has changed from the starting condition to whatever the end state condition is. So unless you're an extreme functional programming zealot, you won't be able to know what the measurements will actually be at that point. And so at boot time is all you really have to work with.
Okay, I won't belabor this point. I'm curious though, Steve. I know we make a big deal about the fact that client attestation can be run subsequent to key release. So especially in containerized environments, you do a platform attestation, and then once the workload is running, they redo attestation and
My,
in
my under, my understanding of that redone attestation is it was just producing the same report again.
I think well, our attestation, there's that, I can't remember what it's called, something data, report data section includes stuff that's in the TCG log. So it's TPM measurements. So,
And the TPM measurements were done at boot.
They get extended by the OS. So some PCRs get extended by the OS. So I know file
But if
system
something has changed in the boot, if something's changed in your OS, you won't pick it up because you'll just pick up the new PCRs that have been added later, which are going to be coming from the workload you added.
Yeah. Personally, I don't trust subsequent attestations. Ultimately, so here's my reasoning. If I measure A and A as measured allows B to be loaded, I don't need to measure A plus B later because I know that A allows B, so I might as well treat it as if B is already there. And if A didn't allow B, then that would be a separate measurement.
I think there's value of being able to recompute an attestation downstream. The question is, what are you recomputing? And so in the world of SGX, you were actually reading memory. And so understanding the state of various components in memory, there's value in knowing your OS is still your OS and hasn't been tampered with. In the case of a CVM, if you load B and B has a defect in it, a 0-day, and somebody finds that 0-day and they then modify the OS, and that's not reflected in the PCRs that cover the kernel, somebody's bypassed your whole subsequent attestation.
But that's the problem is not that B is vulnerable. The problem is that A allowed B to be loaded.
Correct. A allowed code injection.
So for me to be sure that B doesn't get loaded, I need to change A so that it never loads B again. Right. So again, I'm just being mathematically pure here. There's probably going to be a mathematical term for this.
Well, that's why I said the functional programmers go nuts over this because there are no side effects. And with no side effects, you know what the future state will be. So you can do provable OSs, for example. That's whole bunch of research stuff that I think is a long way in our future. You have to know what the attestation is doing, to your point, Mark. And what I'm saying is there are ways around it, because if there's a vulnerability in A even, and somebody's able to inject code into the VM that isn't measured as part of the PCRs, you've just, that subsequent attestation doesn't do anything for you.
Oh, no, yeah, exactly. I think subsequent attestation never does anything for you.
I think it could under the right circumstances, but I think it's a lot of work to prove it.
Yeah.
And Alec, I'll look again at what Microsoft is doing for the running attestation.
Anyway, the point this is not this bullet doesn't talk about that at all. It basically says that if you deployed a new workload but you didn't remove the old measurements, the AVS will continue will allow you to run older vulnerable code.
Correct.
That's really all. It has nothing to do with boot time.
Okay, you can ignore Mark's.
This is about blue-green deployments. This is about gradual
I'll
rollout.
spark for Mark.
Okay.
You want to bold something in that like you've got in all the other sections? Right. You gave a title to what the other two bullet points were.
So the point is unnecessarily large TCPs, security sensitive configuration, and then older vulnerable versions of code.
Yep.
May be may be allowed to run, or
Older code may be allowed to run. Or running older code.
I don't know why this font is busted. It needs to be 11. Okay, sorry.
just reorder the sentence.
Security. I would just say security deployment.
No, just take the second part of the sentence. Older code, older vulnerable versions of the code may be allowed to run by the attestation verification service.
How about just AVS hygiene?
I got to jump to an 8 o'clock call, so I'm going to call it good.
Okay.
But
all right. Well,
saved by the bell.
You are. We still have a few comments here that we need to get through, but okay. We can come back to this in 2 weeks. And
most of them are kind of yours. Let's just, is Nikolai's the last one? Should he clear it?
There's.
Yep, the rest are just you.
Yeah.
Well, look, Steve, while you're here, look at the Mark Bauer one. There are trusted routes for general apps, trusted routes for remote attestation, VSEC, DCAP. Yep. Yeah, let's talk about this some more, Steve, because I mean, if the trusted root store is part of the OS and attestation measurements don't include OS because it's post, boot and post attestation, I don't understand. I kind of got lost a little bit in there.
So the attestation does include the OS. And the PCRs break it into different sections. But once you've written into that TPM, right, by definition, you're not going to be writing into it again. So when you do a subsequent attestation and you provide the attestation of what the OS is, if the OS has been changed since that first call, it's just no longer valid. I really need to jump at this point.
Okay.
We'll talk later. We'll talk.
Okay.
Bye.
Sorry.
All right. Yeah. The thing with this Nikolai's comment is I think there's he's not seeing my point here. Is I'm only checking.
He's on the call now, Mark. So you can actually.
I joined on it now. Unfortunately, I was busy with it on the meeting.
The comments I'm making here, Nikolai, is that we mentioned things here that attestation can catch. It's not about, like, yes, we should always worry about ROP attacks. You should always worry about your supply chain. But under confidential computing, there are some things that you can actually do about it. For instance, with attestation for, attest your configuration. Yes, you always need to worry that your trusted root store is correct. But under confidential computing, you just make sure that it's also the whatever it is you expect to be in the trusted root store needs to be checked as part of your attestation process, and this is why it's listed here, and other things aren't.
I understand that you think I don't see your point. I see your point, but I'm just not entirely sure that it's as convincing to an external person who is not into confidential computing, not a true believer, right? And might say like, well, this is important anyway, and attestation might not necessarily, fully catch it, especially for like data leaks.
So data leaks are not really a question of attestation. That's another one. So say I put things in the log under traditional computing. I can trust my log because of, I consider that to be part of, my environment that I trust. But under confidential computing, I need to ask myself a question. Do I actually trust, the operator of this logging facility, and what can they glean from the logs I put in there? And if I don't trust them, then I need to negotiate a key with the recipient of the log and only put encrypted entries into the log. That, again, under confidential computing, the things that, and I keep coming back to that, the things that you would normally trust, you don't necessarily trust anymore. And you just need to decide.
So the point should be that it's not about that the application needs to be more or less secure. The point is that you need to reassess what you trust and what you don't trust.
Yes,
I think that
correct.
needs to be really
Correct.
highlighted and
Yes.
conveyed to the reader.
Yes.
So that's what I meant. Like when we say like all outputs for data leaks, what needs to be conveyed is that the trust relationship to the different components and processes and so on and endpoints need to be reassessed, because
So
they
that's
might
what we can
not
say, must
be.
reassess the trust relationship, the code, that code running confidentially has with its counterparties. For instance,
Because why I kept commenting was that basically when reading it, my interpretation was like, well, it was okay to have leaky code before, but it's not okay anymore because now you're running T. But if you write it like that, reassess the trust relationships, that's different. That's a whole lot better.
Yeah. So would you be happy with this paragraph stated as is?
Yes, I think it's way better.
Okay. All right. And Sal still needs to speak to, because she mentioned this before. Okay. And I'll circle back with Sal. Mark Bauer, trusted roots for general apps, trusted roots. This in 2 weeks we'll get back with Mark and Steve are on the call. So we will not approve the document yet, just because it has these couple of remaining comments in here. But I think we are almost there. We're right on the cusp.
Yeah. Otherwise, it's quite good, quite mature. Well, I mean, there are endless improvements, but if we can resolve all the comments, yeah. And yeah, sorry, I kind of had a long radio silence. I was missing, but now I was busy with other things, but now I have the time to allocate to join
and
again.
feel free to suggest additional edits on this document. We're probably going to end the call now because we've been a little past the time. Next time in 2 weeks, I'm hoping to present the draft of the attestation verification service governance, and we will move in that direction. And also there is going to be a call just for me and maybe one other person with the CSA's Zero Trust team on Tuesday, and we're hoping to form a relationship with them and hopefully convince them that confidential computing is a critical part to play in Zero Trust.
Yeah, sounds good. Good luck with that. City State.
All right.
Good luck with that.
Thank you.
The CSA will buy in on that.
Fantastic. So we'll talk again in a couple of weeks, and thank you for calling in.
Same. Have a nice time. And
thank you.
Talk to you in 2 weeks. Bye-bye.
Bye-bye.